Hello and welcome, cybersecurity enthusiasts and tech professionals. Today we are diving into one of the fundamental concepts in networking and cybersecurity, the OSI model. Whether you are just starting out or looking to refresh your knowledge, this video is for you. Let's get started. The OSI model, or Open Sister Interconnection Model, is a conceptual framework used to understand and design networks. It has 7 layers, each with a specific function. These layers ensure that the data transmitted over the network is done so efficiently and securely. It helps in visualizing network functions in layer approach, which is useful for troubleshooting network issues and designing efficient network protocols and architectures. Each layer of the OSI model has distinct functions, and this clear separation of responsibility aids in pinpointing where problems may occur in a network. This model is particularly valuable for network engineers and cybersecurity professionals, as it provides a structured way to analyze and secure network communications. Layer 1, the physical layer, is the lowest layer of the OSI model, and its primary function is to transmit raw bits over a communication channel. It deals with the hardware aspect of networking, including cables, hubs, repeater, and other physical aspects of the network. This layer is responsible for establishing and maintaining physical connections. Here are a few key points about it. Transmission of bits. The physical layer is responsible for the transmission and reception of raw bits streams over the physical medium. These could be copper wires, fiber optics, or even wireless transmissions through radio frequency. Hardware components. It involves hardware components like cables, coaxial Ethernet, hubs, repeater, network adapters, and other physical infrastructure that facilitate the actual transmission of data. No data processing. There is not processing of data at this layer. It's purely concerned with the physical connection and the means of transmission. It's about turning digital data into signals that can be sent over the appropriate medium. Role in networks. In network setups, devices like hubs operate at this layer. They simply receive data on one port and broadcast it out to others without interpreting or processing the data. Understanding the physical layer is crucial to ensure strong foundational network connectivity and addressing issues related to signal transmission and physical connection. It sets the stage for more complex functions handled by higher layers in the OSI model. Layer 2, Data Link. Here, data frames are encoded and decoded. It's where MAC addresses live and where switches operate. Framing of data. In the data link layer, bits received from the physical layers are organized into frames. Framing is essential for preparing the data for subsequent and reliable transmission. MAC addresses. This layer is where MAC, Media Access Control, addresses play a crucial role. These addresses are unique identifiers assigned to work interface, Network Interface Cards or NICs, for communication at the data link layer. Error detection and handling. The data link layer is responsible for detecting and possibly correcting errors that may occur in the physical layer. It ensures that frames are error-free and in the correct format. Control of flow and access. It controls how data is placed into the medium, like Ethernet, Wi-Fi, and received from it, including the management of how devices in the network gain access to transmit data. Link establishment. The layer can establish and determine a reliable link between two directly connected nodes. It ensures that the link is effectively set up, managed, and terminated when no longer needed. By organizing data into frames and handling the MAC addresses, the data link layer acts as a bridge between the raw physical network and the more sophisticated functions of the upper layer, like routing and application-specific data handling. It plays a crucial role in the overall function and efficiency of the network. Layer 3 Network. Routers work at this layer. It manages the delivery of data across networks and uses IP addresses. Internet Protocol. This is indeed the most crucial component of the network layer. The IP protocol is responsible for addressing and routing packets of data so they can travel across the network and reach the correct destination. Data packetization. At this layer, frames from the data link layer are packaged into packets. These packets are the unit of data that are routed across the internet or other networks. Vulnerability to attacks. The network layer is susceptible to various cyber attacks. Attacks on routers or routing process itself, like IP spoofing or routing table poisoning, can disrupt network operations. Securing the network layer involves safeguarding routing processes and devices. This can be done through encryption, access control lists, firewalls, and intrusion detection system. Your understanding of this aspect is vital in cybersecurity as it helps ensure data is securely and efficiently routed across networks. Layer 4 Transport. Ensuring complete data transfer. This layer is where TCP and UDP protocols operate. Point-to-point communication. The transport layer is responsible for providing end-to-end communication between devices. It ensures that the data is transferred from one point to another reliably and error-free. Data segmentation and reassembly. In this layer, data is broken into smaller packets for transmission and then reassembled at the destination. Error handling and flow control. It manages error detection and correction, ensuring that data is correctly sent and received. Flow control is also handled here to prevent network congestion by controlling the speed of data transmission based on the receiver's capabilities. Protocols. This layer includes critical protocols like TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. TCP provides reliable, order, and error-check delivery of data, while UDP is simpler, providing a connectionless service with less overhead. Importance in cybersecurity. The transport layer is important for cybersecurity because it is where you ensure the reliability and integrity of data transmission. Understanding the transport layer functionalities help in ensuring secure and efficient data transmission, which is essential in network design and cybersecurity. Layer 5 Session. This layer is crucial for managing and controlling the connections between computers. It establishes, maintains, and terminates the connections or sessions between remote applications. Here are the key points and functions of the session layer. Session establishment, maintenance, and termination. It handles the setup, coordination, and transmission of sessions. These include establishing session parameters, managing session IDs, and negotiating data transfer rates. Dialog control. The session layer allows for the control of dialogues between applications. It can manage duplex or simplex communication, ensuring that the data flow is properly synchronized. Synchronization. It provides mechanisms for adding checkpoints into the data stream, allowing for recovery from errors and data loss. For example, if a session is interrupted, system can resume data transmission from the last checkpoint. Cybersecurity considerations. The session layer is target for attacks aimed at disrupting or hijacking sessions. Security measures at this layer often involve implementing encryption for session data and strong authentication protocols to verify the identity of communicating parties. Layer 6, the presentation layer, plays a crucial role in how network applications communicate with each other. It acts as a translator, ensuring that the data transferred from the application layer on one system can be understood by the application layer of another. Here there are key aspects and functions of the presentation layer. Data translation. converts data from a format used by the application layer into a common format at sending station, then back it into a format understandable to the application layer at the receiving station. Data compression reduces the size of the data being transmitted, which is crucial for efficient data transfer, especially in environments with bandwidth limitation. Data encryption and decryption ensures the data is securely transmitted over the network by encrypting the data before it's sent, and decrypting into the receive and the presentation layer plays a crucial role in the network security. Interoperability facilitates the interaction between different encoding methods used by applications and networks, ensuring that the data can be exchanged between different systems seamlessly. Optimization of network communications. Through compression, the presentation layer helps in optimizing bandwidth use and improving the speed of data transmission. An example of use is character encoding, translating characters encoding formats such as ASCII, EBCDIC, and Unicode. Cybersecurity consideration. Given its role in encryption, the presentation layer is crucial for protecting data privacy and integrity. It's a target for attacks aimed at compromising the data through methods such as encryption breaking and data format manipulation. Layer 7, the application layer, is the topmost layer and serves as the interface between the users and the network. It provides services directly to user applications and facilitates user interactions with the network. This layer covers a wide range of functionalities, including file transfer, email, and web browsing. Here are the key aspects and functions of the application layer. Network service to end user. It provides end user service and enables users to access the network. It includes everything from web browsing and email to network data sharing and online chat services. Application protocols. This layer includes a variety of protocols that define the rules for data communication between applications. Examples include HTTP for web browsing, SMTP for email, and FTP for file transfers. User interface. The application layer is where users interact with applications to send and receive data over the network. It's responsible for displaying, receiving information, and managing user inputs. Importance in networking. Seamless communication. It allows different networks applications to communicate in a way that is transparent to end users, providing a seamless network experience. Application-specific service. Tailor network communications to specific needs of application, ensuring that the data is presented and managed in a way that applications can use effectively. Examples of use. Web browsers, interacting with web servers using HTTP or HTTPS to access or submit information online. Email clients, sending and receiving emails through SMTP, POP3, or IMAP. Online gaming, connecting to game servers, providing real-time interactions and gameplay with the users around the world. Cybersecurity considerations. The application layer is common target for cybersecurity because it is directly accessible to the users and encompasses a wide range of activities that can be exploited, such as malware, software designed to harm or exploit any programmable device, service, or network. Phishing, attempts to acquire sensitive information by masquerading as a trustworthy entity in electronic communications. SQL injections, inserting malicious SQL statements into an entry field for execution. Understanding the application layer's functionalities is crucial for developing secure network applications and protecting them against a wide range of cyber threats. Security measures at this layer include using secure protocols like HTTPS, implementing authentication and authorization checks, and ensuring data input validation to prevent injections and other exploits. Why is the OSI model important in cybersecurity? In cybersecurity, understanding the OSI model helps in identifying potential security threats and points of vulnerability. For example, knowing that firewalls operate at the network layer can help in designing various security protocols. Each layer has its security consideration. For instance, encrypting data at the presentation layer or ensuring security sessions at the session layer. The OSI model is more than just theory. It's a lens through which we can understand and secure our networks. For cybersecurity professionals like us, it's a roadmap to navigate the complex world of network communications and security. For now, stay secure.